Hi folks, Nigel Davis, Eastern Washington University, Eastern Geology. Not here to scare you, here to give you the lesson. We're here for what would have been spooky science. Wahahaha, spooky science. We are unable to frighten you in person. Well, first off, I'm gonna remove this so you guys can all see my face and hear my voice a little clearer. We're gonna walk through our fluorescent minerals and understand the process of fluorescence. So, we've got a variety of different minerals up here and some rocks that are not going to fluoresce. Walk you through why this happens. Now, I've seen some hacks where people use the backside of their phone, some tape, and some blue Sharpie markers to turn their camera into what they think is a UV light. That does not work. It will give you a nice purpley blue hue, and it might accentuate highlighter, but it is most certainly not gonna give you actual fluorescence. You do need a fluorescent light. Well, let's get rid of the tape, because we don't need that. Here's what this is gonna look like, and I'm gonna do this hopefully such that you guys can see. Before we turn the lights off completely, let's walk through the chemical situation here. Now, we've got a variety of different minerals. The common setup here, I've got some calcite, some opal, but the common setup is this sequence of minerals, which has Willemite, calcite, and Franklinite. And it comes from Franklin, New Jersey. This is a zinc silicate, calcium carbonate, and a zinc iron oxide. In fact, this is an ore of zinc that would be mined. So inside this rock, we're gonna see what happens. And we're gonna see two different processes of fluorescence. So here's what that Franklinite, calcite, and Willemite looks like. The dark black bits are the Franklinite. They actually do not fluoresce. The orange that you're seeing is the calcite fluorescing, and the little bits of green in there are the Willemite. Wah! And this is all happening because there's extra manganese floating around that's actually incorporated itself into the calcite structure. So that extra manganese is enabling the fluorescence of both the Willemite and the calcite. This happens in just regular calcite as well. It can happen if there's a little bit of uranium caught up in quartz that's in an opal. And all of these fluorescences require excitation of an electron through the stimulation of the UV light, bwahaha, and then the return or the drop in energy of that electron back down to its stable form. And that drop in energy is what we are getting to see as the fluorescence. So we get this jump in energy exposed to the UV light, and then this drop is them fluorescing for us. Thanks for joining Eastern Geology for Spooky Science. Have a great day. In a scary way.